Okay. So the warm-up, it says Billy Bob is taking his midterm, which has 20 multiple choice questions. He's not feeling confident at all, but he knows he can get 5 questions right. And then he'll have to guess on the remaining questions. Each one's a multiple choice that has 5 options. And then if he needs 15 questions to pass his midterm, what is the probability that he passes the midterm? Okay, so I'm just going to highlight some important information here. It's a 20 multiple choice midterm. He knows he can get 5 questions right, and then he'll have to guess on the remaining question. Every answer choice has 5 options. And then he needs 15 questions correct to pass his midterm. So we want to know what is the probability that he passes the midterm. So to kind of walk us through this, the first thing is we need to figure out how many questions is he guessing on. Well, if there's 20 questions and he knows he can get 5 questions right, that means he's guessing on 15 of the questions. Okay, this is a binomial problem. And then it says how many more questions does he need to get right in order to pass his midterm, assuming that he gets the questions he thinks right. So he needs 15 questions to pass the midterm, and he knows he can get 5 questions right, which means he needs 10 more questions right. So then now we're going to use what we answered to find the probability that he passes the midterm. Okay, so we have n, that's 15, that's how many questions he's guessing on. We have p, because it's a multiple choice question and there's 5 options. So his probability of guessing right is 1/5. And then we're trying to find this. We're trying to find the probability that he gets 10 or more questions right. So greater than or equal to 10. So remember what we learned before our little break, that anytime we have a greater than symbol here, we have to rewrite that as 1 minus the leftover. So that's going to be 1 minus the probability that x is less than or equal to 9, because remember that number drops down. So if we want the probability of 10 or more, because our calculator only gives us the area to the left, we have to do 1 minus the leftover, whatever number's to the left of 10. Then we can put this in our calculator. So to put this in our calculator, it's going to be 1 minus binom. And since it's an inequality, not an equal sign, we're going to use binom CDF. And remember the order is NPK. So 15, 1/5, and then K is whatever it is written with a less than or equal to symbol. Okay, so then we can use this calculator. So I posted a link in Google Classroom for a calculator that you guys can download on your computers that looks like a TI-85. Hold on, let me see if I can share this. And you get a 90-day trial. So let me see. Where is the calculator? Maybe I can't show you the calculator. Well, anyways, you should use that link because you can get a calculator that's works pretty well if you don't want to get this iPhone calculator. So the calculator I have on the screen that you guys can see is that one that I downloaded for like $5 or whatever. So anyways, so to put this in our calculator, we're going to do 1 minus, and then to get binom CDF, we're going to hit second vars for distribution. And using this calculator, you can see here binom CDF is right here. And then we put it in the order NPK. So 15, comma, 1/5, comma, and then K in this case is going to be 9. So this gives us 0.0001. So that's the probability that he passes his midterm. All right, do you guys have any questions about that example? No? Okay. So I'm going to go ahead and move on to the next one. So this is going to be kind of a mix of all the stuff that we talked about in Unit 6, just to kind of refresh your memory. All right, so this one says, patients receiving artificial knees often experience pain after surgery. The pain is measured on a subjective scale with possible values of 1 to 5. Let X be the pain score. The following table gives the probability distribution for X. Okay, so here's our table. And remember that the sum of the probabilities in this table all have to add up to 1. So all of these equals 1. So if we're trying to find the probability that X equals 5, we need to find this missing information. So what we need to do is we need to add up all the probabilities. So 0.1 plus 0.2 plus 0.3 plus 0.3. So it's 0.1 plus 0.2 plus 0.3 plus 0.3. That's 0.9. And then to find the missing one, we subtract that from 1. That equals 0.1. Someone just leave? Or did someone just enter? Oh, okay. So the probability that X equals 5 is 0.1. Okay, so the key thing that you need to remember here is that the sum of the probabilities in a probability table always equal to 1. All right. The next one, I think there's a way that you can react if I'm going too fast. Remember, if you have questions, just unmute yourself and interrupt me, but I'm also checking the chat here and there. Okay. The next example. Okay, question 2. So same thing, patients receiving artificial knees, blah, blah, blah. Okay, but now we're trying to find a different probability. We're trying to find the probability that X is less than or equal to 2. So that's going to be these two added together. So this is a pretty straightforward example. We just have to add them. So 0.1 plus 0.2 equals 0.3. So probability that X is less than or equal to 2 is equal to 0.3. So don't forget about context for this problem, since we're talking about pain scale. That's basically saying what is the probability that a selected patient has a pain scale of 2 or less. So that's what that means in context. All right, the next example here. So as a machine fastens plastic screw-on caps onto containers of motor oil. If the machine applies more torque than the cap can withstand, the cap will break. Both the torque applied and the strength of the caps vary. The capping machine torque T follows a normal distribution with a mean of 7 pounds and a standard deviation of 0.9 pounds. The cap strength, C, so the torque that would break the cap, follows a normal distribution with a mean 10 inch-pounds with a standard deviation of 1.2 inch-pounds. What is the probability that a randomly selected cap has a strength greater than 11 pounds? So this is actually a z-score problem. So we're looking for a randomly selected cap that has a strength greater than 11 pounds. So we're looking at cap strength. So this problem actually gives you more information than you need. They give us information of the torque, but we're not going to use that. And they give us information about the cap strength, which is what we are going to use. So the mean and the standard deviation. Okay, we're going to use this 11. So remember the z-score formula is x minus mu over sigma, and we're just going to plug in. So x is going to be, my notes are Okay. Sorry, my dogs are annoying. Okay, so anyways, using the z-score, x is going to be 11. The mean that we're going to use is 10 since we're referring to cap strength. So 11 minus 10 over the standard deviation is going to be 1.2. So 11 minus 10, oops, divided by 1.2 is 0.83. So that's our z-score. Now what we need to do is we need to figure out what that is using our z-score table. So we're looking for a cap strength greater than 11 pounds. So we're trying to find the probability that z is greater than 0.83. With z-score problems, remember that we are subtracting from 1 anytime we're looking for greater than. So we're going to look at our z-score table, which, let me pull that up. Okay, so here's my z-score table. Here's my z-score table. So we're looking for 0.83. And if you guys don't have your z-score table, like you left it at school, you can always just Google z-score table and you'll find it. So we're looking for 0.83, which is going to be right here. So 0.7967, and we're going to subtract that from 1. So 1 minus 0.7967. Okay, so subtracting that from 1, so 1 minus 0.7967, that's 0.2033. That's going to give us the probability that a randomly selected cap has a strength greater than 0.11 pounds. So this is just a z-score problem. So the couple problems that I went over are just about random variables. So these are just question 1, these were discrete random variables. Same with question 2, discrete random variables. The third one was a continuous random variable, which is just a z-score problem. So the Khan Academy assignments that I have posted are kind of has a mix of those. It has some discrete ones and it has one with normal distributions, which are just z-score problems. All right. I'm going to go ahead and do the next example unless anyone has any questions. Okay, so the next example here, it says, according to Mars Incorporated, 20% of its plain M&M candies are orange. Assume that the company's claim is true. Suppose you reach into a large bag of plain M&Ms without looking and pull out 8 candies. Let X be the number of orange candies you get. Find the probability that 5 or more of the candies are orange. So this is a binomial problem because you're thinking there's 2 options. It's either orange or it's not. So to figure this out, we need to identify N and P. So N is how many candies you're grabbing, which is 8. P is the probability of success, which in this case, a success would be an orange candy. And since it's 20%, P would be 0.2. And now we're going to write it as an inequality. So we're trying to find the probability that X says 5 or more. So that's going to be greater than or equal to 5. 5 or more of the candies are orange. Okay. So before we can put this in our calculator, remember that we have to rewrite it anytime we have a greater than symbol. We do 1 minus the leftover. So less than or equal to 4. Because if you think, right, if you're pulling out 8 candies, these are the only options for how many candies orange candies you can pull out. You can pull out 0, 1, 2, 3, all the way up to 8. If we're trying to find the probability that it's 5 or more, this is what we're looking for. The thing is, our calculator only gives us less than. Our calculator will only give us 5 or less. So in order to get 5 or more, remember that these probabilities always add up to 1. So that's why we write it as 1 minus whatever the leftover is. The leftover is 4 or less. So that would give us the amount that we're looking for. Okay, so once it's written like that, that becomes our K. Now we can put it into our calculator. So we're going to do 1 minus binom. We use CDF because it's an inequality. So it's going to be N, P, and then K is going to be 4. Okay, so we're going to do 1 minus second vars binom CDF. You do need to make sure you choose CDF, because if you choose PDF, it's only going to give you the probability that X equals 4, but we want 4 or less. So 8.2 and then 4. So then that's our probability, 0.010. Well, I'll put 0.0104. So that's a probability that if you were to reach your hand into a bag of M&Ms, that 5 or more of the candies were orange, if you pulled out 8 candies. All right, any questions on that example? Okay, if you hear chewing in the background, it's my dog here for a little video break. Wait, I don't know how to do it. Oh, I can't see him. I don't know where he is. Okay. You see him? Charlie? Okay. Anyways, I'll keep us moving. I won't keep you guys show you videos of my dog. Okay. So the next example here is this one. So this is an expected value problem. It says let y denote the number of broken eggs in a randomly selected, what does it say? Carton of 1 dozen store brand eggs at a local supermarket. Suppose that the probability of distribution is as follows. We're going to calculate the expected value. Okay, so remember, to calculate the expected value mathematically, what you're doing is you are just multiplying, sorry, hold on. You are just multiplying these numbers here, and then you add them all together. So to calculate the expected value, and then I'll show you how to put it in your calculator, you're going to do 0 times 0.78 plus 1 times 0.11 plus 2 times 0.07 plus 3 times 0.03 times, plus 4 times 0.01. Okay, so that's what you're doing, but there is a way that you could put it in your calculator if you have one of these calculators. So you're going to go to Stat, Edit. Okay, as you can see, I actually already put this in there. You're going to put in the top row into list 1, and then you're going to put the probability into list 2, like I've done here. And then to calculate the expected value, you're going to hit Stat, Calc, 1var stats, and then you're going to put list 1 into list, and then for frequency, you're going to put list 2, and then calculate. And remember, expected value in our calculator is the mean or the average, so we look at X bar. So the average is going to be 0.38. So there's an expected value example where the table's already given to you, and you don't have to make the table. Okay, so let's look at an example where we actually have to create the table. This is a good opportunity to bring up Casino Day. Obviously, Casino Day is postponed, maybe canceled. So in terms of your casino projects, don't worry about it right now. Just focus on any of the extra work that I'm giving you. But obviously, you don't need to be working on your casino project, which kind of sucks because that's a fun activity or a fun event. All right, so let's look at question 6. It says a deck of cards contains 52 cards, 4 of which are aces. You're offered the following wager. If you draw 1 card, You'll win $10 if the card drawn is an ace, and you're going to play $1 to play this game. What are your expected winnings? So remember, when we're creating our table, there's three rows. The first one is the outcome. The second one is the profit. And then the third one is the probability. Okay, so in this game, since all you're doing is drawing a card out of a hat, there's really only two outcomes. You either draw an ace or you don't draw an ace. Okay, if you do draw an ace, you win $10. However, since you're paying $1 to play the game, you have to subtract that, so your real profit is actually going to be $9. And if you don't draw an ace, you're going to lose. You don't win anything, which really means you lose the dollar that you paid to play the game. So that's what it would be for profit. Okay. Then to find the probability, you just have to figure out what is the probability of that particular outcome of happening. So the probability of choosing an ace, since there's 4 aces in a deck, it's going to be 4 out of 52, which means the probability of not drawing an ace would be 48 out of 52. So once you have your table drawn, then you can go ahead and calculate your expected value. To calculate your expected value, you're going to multiply the profit times the probability and then add them together. So -1 times 48 out of 52. So since that's a pretty short one, you can just put that directly in your calculator. So 9 times 48, 9 times 4 out of 52, -1 times 48 out of 52. So your expected value for this game is -0.23, which means you're going to lose 23 cents on average each game. And remember what that expected value means is if you were to play this game over and over and over and over and over again and calculate your average winnings, you would actually be losing about 23 cents per game. Hold on, I'm going to kick my dog out. Charlie, come on. Come here. Charlie, come. Charlie, come here. All right. Okay, let's look at the next example. So it says in a certain game of chance, your chances of winning are 0.2. If you play the game 5 times and the outcomes are independent, what is the probability you win at most once? So here's how you can tell the difference between these, like an expected value problem versus a binomial problem. Binomial problems usually have something like, what is the probability you win at most once, where it's referring to some type of inequality. Also, the fact that they mention that they're independent also indicates to you that it's probably a binomial problem, because remember that was one of the conditions of a binomial experiment. So those are the kind of the keywords that you can determine, okay, is this an expected value problem? Also, expected value problems will usually say the word expected. So that's how you can kind of tell, like, okay, I'm supposed to make a table versus I'm supposed to do binom, CDF, or PDF. Okay, so question 7. This is a binomial problem. Binomial problems, we identify N and P. So N is the number of trials. So we're playing the game 5 times. So that's going to be N. P is your probability of success, which in this case is going to be 0.2. And then what we're going to do is we're going to write this at most once as an inequality. So that's a probability. At most once means 1 or less. So X is less than or equal to 1. So this one we don't have to rewrite because it's already written as less than or equal to. So then we can go straight to putting it in our calculator. So it's going to be binom CDF. N is 5, P is 0.2, and then K is going to be 1 for this problem. And we don't subtract from 1 because we're not looking for greater than. So second vars, binom CDF, 5 comma, 0.2, comma, 1. It's going to be 0.7373. So that would be your probability of winning at most once. So the reason why this one is CDF, not PDF, is because, sorry, my dogs are barking. Hold on. Charlie. We only use PDF when there's an equal sign. Okay, get up. Yeah, that's a good question. So we only use PDF when there's an equal sign, and then we use CDF when we have a less than or equal to symbol. Okay, and then in terms of subtracting from 1, we only subtract from 1. So we do 1 minus something if we have a greater than or equal to symbol, because just like the z-score table, our z-score table only gives us less than. Our calculator will only calculate less than. Okay. Any other questions about this one before I move on to, I have 2 more questions. You guys are doing great. Well, actually, I don't know how you guys are doing. Hopefully you're doing great. Okay. Let's look at question number 8. So it says 13 people have been exposed to a particular disease. Each one independently has a 35% chance of contracting the disease. A hospital has the capacity to handle 7 cases of the disease. What is the probability that the hospital's capacity will be exceeded? Okay. So again, this is going to be a binomial problem. Some key words here is it does say independently. It doesn't say anything about the expected value or anything like that. Okay, so for this problem, we're going to identify N and P. So N is the number of trials or observations. In this case, there are 13 people. So that's going to be N. P is the probability. In that case is a 35% chance, which is going to be 0.35. And then hospital's capacity will be exceeded. We're trying to find the probability that X exceeded means more than. So if the hospital can handle 7 cases, what would exceed their capacity is 8 or more. So we're trying to find the probability that X is greater than or equal to 8. So this one's a little bit tricky because of the word exceeded. Exceeded means to go beyond. Well, the numbers that are beyond 7 would be 8, 9, 10, etc., all the way up to 13. So this one, we are going to use CDF, but we do have to subtract it from 1 since it's a greater than or equal to symbol. So it's going to be 1 minus the leftover. And the inequality indicates to us that we're going to be using CDF. So that's going to be 1 minus binom CDF, and then NPK. So N is 13, P is 0.35, and then K is going to be 7 in this case. So then we can go straight to our calculator for that. 1 minus, and then second vars, binom CDF, it's going to be 13, 0.25, or sorry, 0.35, and then 7. So that's going to be 0.0462. So the probability that the hospital's capacity will be exceeded is 0.0462. All right, we have one last question here. All right, so going back to the Billy Bob example, except now like from the warm-up, but now I'm not really giving you any information, or I'm not walking you through it. So it says Billy Bob is taking his 40-question multiple choice midterm. He's not feeling confident at all. He thinks he can get at least 10 questions right because his teacher is so nice that she put 10 questions for the midterm on his practice midterm. and he knows he'll be able to guess on the remaining question. Each multiple choice question has 5 answer choices. So he needs a 22 out of 40 to pass his midterm. What's the probability he scores at least 22? Okay, assuming that he gets right the 10 questions. So let's first figure out how many questions he's guessing on. Well, if there's 40 questions on the actual midterm, but he knows he's going to get 10 right, we can subtract those and determine that he's only guessing on 30 questions. So that's going to be our N. P is going to be the probability that he guesses right. Well, if each answer choice has 5, or if each question has 5 answer choices, the probability of him guessing right is going to be 1/5. And then we need to figure out what we're calculating. Well, we're trying to find the probability that he gets at least a 22, which is a greater than or equal to symbol. Okay, but remember that he feels like he's going to get 10 questions right. So if he's going to get 10 questions right, he only needs 12 more correct. So 22 minus 10 would be 12. So this is what we're trying to calculate. We're trying to calculate the probability that the number of questions that he guesses on, he gets 12 or more of them correctly. That's what this is looking at. Okay, so this one, once it's written out like that, it's pretty straightforward. We just have to first rewrite it as 1 minus, because it's a greater than or equal to symbol. So 1 minus 1 minus the probability that x is less than or equal to the leftover. The number to the left of 12 is 11. And once it's rewritten, that's our k. So we're just going to do 1 minus binom CDF, and then NPK. So N is 30, that's how many questions he's guessing on. P is 1/5, that's the probability that he guesses right. And then K is going to be 11. So that's what we put in our calculator. So 1 minus binom CDF, 30, comma, 0.5, comma, 11. That's going to be we'll say 8998. Oh wait, I feel like I did something wrong. Oh, oops. That's not right. I was gonna say that probability seems kind of high. I put it in my calculator wrong. So it's 1 minus binom CDF, N is 30, P is 1/5, not 0.5. And then K is 11. The probability that I had calculated was if it were true or false questions, what would be the probability of him guessing right? But they aren't true or false, they're multiple choice with 5 answer choices. Okay, there we go. That seems right. So 0.009. So 0095 we'll say, which is pretty low, so he probably does not have a very good chance of passing his midterm if he is truly guessing on 30 of the questions. Okay, I think that is it. Let me turn my camera back on. Do you guys have any other questions I can answer about these ones? So remember that this is all review. We did go over this stuff before school closed. We had just finished binomials, and then we were going to kind of transition into midterm review. I think the CDF ones was a lesson I taught on Friday. Any questions? And then let me just show you in Khan Academy some extra problems that you could do. All right, so in Khan Academy, hopefully you guys can see my screen here. Yeah, so in Khan Academy, there's these 4 assignments here. So probability with discrete random variables, that's one where the table, and you just have to like add them together. Expected value problems are the ones where you might have to make the table and then calculate the expected value by multiplying and then adding. Probability and normal density curves are the z-score problems. And then calculating binomial probability is the binom CDF PDF ones. But these assignments only have like 4 or 5 problems in them. It's just good practice. The other thing I would advise that you do is, well, I put it on here. It says for homework, you can work on the Unit 6 practice test, which in Google Classroom, if you go to classwork, the practice test is here, because I really have taught you everything from this unit. So for you to kind of get an idea of how much you remember, you can go ahead and do the practice test. There's a YouTube video that goes over the whole thing, as well as the key. So that's what you can do for homework to review. But again, everything's optional as of now. I'm not planning to collect any of this. It's kind of just for your own good. So if that's something that you guys want to do, feel free. If not, that's totally fine. I think starting maybe tomorrow, I might maybe do every other day. I don't know. I haven't decided. I thought more people would attend, but I guess not. Probably starting Wednesday, I might start the new unit. So I might give you guys a day to kind of figure things out and how you want to do this. And then starting on Wednesday, I might just start the new unit. Okay. But if you guys don't have any other questions, I'm going to go ahead and end the meeting. Anything? You are very welcome. Tell other people in the class to join. I mean, I know I'm saying this and I'm like beating a dead horse here, but like it is really important that you try and keep up with this stuff, because it's going to be hard to get back in the swing of things if you're going to wait until, who knows when. So if you can tell people in the class to try and join if they can, but I am going to also post the link to this video in Google Classroom. All right, well, I hope you guys stay safe and healthy. Make sure you're still exercising and getting out and getting some nice sun and stuff. All right, I will talk to you guys next time. Have a good rest of the day.